Hello everyone, let me introduce myself. My name is Keisya Azzahra AURALYN Handoko with SID 102012400277 from the E48 Inter. On this occasion, I will present a journal entitled Application of Integrated Cooperative Learning (NHT) and PSTS in Overcoming Learning Difficulties in Atomic Structure and Periodic System of Elements. This journal was written by M. Harif, M. Muntari, and E. N. Loka and published in the Pijar MIPA Journal in 2019. This research discussed how cooperative learning methods consisting of numbered heads together or NHT and two-state two-stray or TSTS can help students understand complex chemical material such as atomic structure, electron configuration, quantum number, and periodic table. This article aims to improve students' understanding through an interactive and collaborative approach. Before getting into the main discussion, there are two questions that are the focus of this journal. First, how do the NHT and TSTS learning methods help students understanding atomic structure and the periodic table? Are the steps in this method able to explain concepts that are often considered difficult? Second, what impact does the application of this cooperative method have on student understanding, especially on concepts such as electron configuration and quantum numbers? Through these two questions, we will explore the result of the research presented in the journal. Next, let's briefly discuss the contents of the journal. The method applied in this study are NHT and TSTS. In the NHT method, students work in small groups, where each member is responsible for understanding the material and explaining it to other members. For example, if the material given is the electron configuration of the oxygen atom, then each student in the group must understand how to write the configuration such as 1s2 to s2 to p4. The TSTS method or two-state two-stray provide an opportunity for two students in a group to stay in place and explain to other visiting students. The other two students will go to other groups to get additional information. The results show that this method was very effective in improving student understanding of atomic structure, electron configuration, and periodic table. Students are more active in discussing and helping each other to clarify difficult concepts. This journal is very relevant to the material we are studying, namely atomic structure, electron configuration, quantum numbers, and periodic table. First, modern atomic theory is explained in more detail through this method approach. For example, the concept of quantum number that are often considered difficult, such as the main quantum number for energy levels, azimuth for orbital shape, magnetic for orbital orientation, and spin for the direction of electron rotation can be better understood through group discussion. Second, the electron configuration becomes clear. For example, a sodium atom with an electron configuration of 1s2 to s2 to p6 3s1 can be studied by tracing how electrons are arranged in orbitals according to Aufbau rules. Third, the periodic table can be explained by relating the electron configuration to the position of the element in the group and period. For example, the last electron in the 3s subshell for sodium explains why this element is in group 1a and period 3. Here is one example of the application of this method in the classroom. For example, students are given an assignment to write the electron configuration of group 1a elements such as sodium, potassium, and lithium. In the NHT method, students discuss in small groups and explain to each other how to write the electron configuration. They also discuss how the last electron determines the position of the element in the periodic table, while in the TSTS method, two students from the group explain the result of their discussion to other groups, and the other two students get information from different groups. Through these activities, students not only understand the electron configuration, but can also see its relationship with the chemical properties of elements in the periodic table. such as high reactivity in group 1A. From this journal, we can conclude several things. First, the NHT and PSTS methods are proven effective in improving students' understanding of atomic structure and periodic table materials. This method encourages active interaction between students so that they can learn from their mistakes and improve their understanding. Second, complex concepts such as quantum numbers and electron configuration can be explained more easily through this cooperative approach. Third, the application of this method not only improves students' conceptual understanding, but also their communication and teamwork skills. In closing, I recommend this method to be used in learning other chemistry materials, especially those involving abstract concepts such as the chemical reaction or chemical bonds. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.